Okay guys, today we're going to talk about multiplying and dividing rational expressions. So, starting off, we're going to talk about how to simplify a rational expression. To simplify a rational expression, we're going to start with A, B, and C being expressions where B and C can't be zero. So what we're going to be able to do is take a fraction, AC over BC, and we would be able to simplify canceling out that common factor, that C, which would just leave us A over B, basically how fractions work. Now, let's take a look at this with a number. Say something like 18 over 60. If we were to factor both of those, they would factor into 6 times 3 and 6 times 10. That 6 is common to the two factors, so we can cancel it out, giving us 3/10. Okay? Now, this is going to be true for expressions that are more algebraic in nature and not just constants. So take something like 4x plus 3 and divide it by x plus 3 times x minus 2, and that common x plus 3 factor is going to cancel out, leaving just 4 divided by x minus 2. Okay, so the same properties that work for fractions all those years ago are still going to work now, except we're just canceling out expressions as opposed to just numbers. Okay, so following these steps, step 1, you're going to factor the numerator and the denominator. Numerator, of course, is the top of the fraction. Denominator is, of course, the bottom. So factoring the top and bottom of our fraction. Then step 2, we're just going to cancel out any common factors. So let's do a couple of examples here. Start off real simple. So example A, let's take x squared plus 5x divided by 6x. Obviously, we can do the GCF here, factor out an x, and that's going to give us x plus 5. So x times x plus 5 over 6x. The x's cancel out, and that's just going to leave us with x plus 5 over 6. Let's see. Let's take something a little more complicated. Let's do another example here. X plus 4 divided by x squared minus 16. And so at this point, I hope you can recognize very quickly the difference of squares. This is going to give us x plus 4 on top. And on the bottom, we'll have x plus 4, x minus 4. Canceling out the x plus 4 gives us just 1 over x minus 4. Okay, so we can also do this with things that are trinomials. So let's take another example here. And we can take x squared minus 2x minus 3 and divide that by x squared minus x minus 6. So go ahead and factor those two trinomials. We get x minus 3, x plus 1, and then we get x minus 3 and x plus 2. Canceling out, the x minus 3 cancels out top and bottom, leaving us with x plus 1 over x plus 2. Okay, so very quickly we can see how important our ability to factor comes into this. It saves us a lot of time and energy knowing how to factor and factor quickly. All right, so moving forward, beyond just simplifying, we also would like to be able to multiply our expressions. Now, Multiplying rational expressions works the same as multiplying fractions. A over B times C over D just becomes A times C over B times D. We just multiply the numerators and multiply the denominators. So, steps for multiplying rational expressions. We're again going to start off by factoring. So we're going to factor both the numerator and the denominator again. So again, factor the top and bottom. Now here's an important step that a lot of people kind of forget to think about, is that we're going to simplify before we multiply. So simplify before we multiply. And to simplify, we're going to cross cancel.
Hi, Daddy.
All right, after simplifying, we're going to go ahead and then multiply the numerator, multiply the numerators and the denominators together. So multiplying the numerators and then separately multiplying the denominators. Okay, and then finally, if possible, we'll simplify some more. Not often possible, but if you can, do. All right, so let's go ahead and take a look at a couple of examples, see how this works in practice. Let's take, so 20x minus 5x squared divided by x squared minus x, and we're going to multiply that times x squared plus 3x minus 4 divided by x squared minus 16. Okay, so once we've done this, we're going to go ahead and factor this all out. So GCF on this first part, 5x and 4 minus x. And on the bottom, we just have x times x minus 1. And then in the second part, we have x plus 4, x minus 1, divided by x plus 4 and x minus 4. Okay, so when we start canceling out here, we can see there's some things that cancel out very quickly. X plus 4 and x plus 4 cancel out. X minus 1 and x minus 1 cancel out. We have the x's here canceling out. Now, what it may be harder for you to notice or see is that if we factor out a negative 1, so make this negative 5, we could reverse these two numbers, making it x minus 4, at which point we can then cancel out the x minus 4 and the x minus 4. So when we're all said and done, this whole complex expression equals negative 5. Okay? So we can see very quickly how small and simplified these can become. And a lot of it comes down to being able to factor, recognize different patterns here. So let's go ahead and do another example. This one a little different than the last. So let's take something with multiple variables this time. So we have 5x squared y to the third divided by 3x y to the fourth times 27 x to the fifth divided by 15 x to the fourth y. Okay, so in this case, there's not a whole lot that's going to be able to cancel out as far as factoring goes, but we will still be able to cross cancel and simplify in some places. So let's go ahead and take a look at what we can cross cancel. The 3 and the 27 are going to cross cancel. So the 3 becomes a 1. The 27 becomes a 9. The 5 and the 15 cross cancel. The 5 becomes a 1. The 15 becomes a 3. And we can cross cancel some of these x terms as well, right? So x2 is going to cancel with the x4. So we have x to the second on the bottom here. We have, we can cancel out the y here and that third, making it a second. We can cancel out an x and one of these x's, making that to the fourth. So let's write what we've got so far, multiplying this together. So we have 1 times the x's cancel out, y to the second. So we have 1 y to the second times 9 x to the fourth over 1 y to the fourth times 3 and then x squared. So as we can see, we have this kind of intermediate step where we can continue to clean this up some. We have some y's and x's that'll continue to cancel out. x2 cancels out, or the y squared and the y to the fourth will simplify. X squared and x to the fourth will simplify. And then we can just multiply those constants. 9 times 1 equals 9. So we have 9x squared over 3y squared. And we can simplify one last time now with these constants. 9 divided by 3 is obviously just 3. So 3x squared over y squared. Obviously, there's a lot of intermediate steps there that could have gone a little bit differently. But in the end, we're all going to get the same result. A simplified, nice multiplication between two rational expressions. Okay? Let's do one more example here. This one where we have a polynomial times a rational function. I think that will cover these examples. So we go x minus 4 and x to the third plus 8. We're going to multiply that times x squared minus 2x plus 4. Now, we're going to go ahead and factor these two expressions. X minus 4 doesn't factor. And the bottom is the sum of cubes. So we will factor that sum of cubes to x plus 2. And then x squared minus 2x plus 4. So keep working that pattern if you don't have that one figured out yet. And then we'll go ahead and factor that top expression. Oh, wait, it doesn't factor. So it's just x squared minus 2x plus 4. But it does look familiar. So we can put this over 1. And now when we look to cancel out, this trinomial cancels out with that trinomial. And we have just x minus 4 divided by x plus 2. Okay? So, gives you a pretty good idea of what to expect when you're looking at multiplying rational expressions. The last piece of this is dividing rational expressions. Now, dividing rational expressions is very much like multiplying rational expressions, except we need to use that famous rule from our elementary school days, where if we take a over b and we divide it by c over d, we're going to multiply by the reciprocal. So multiply by the reciprocal of the second term. So we end up with multiplied by d over c, and then we just multiply straight across ad over bc. Now, when you were in elementary school, you may have learned it as keep, change, flip. So 2/3 divided by 7/8. We would keep that first number the same, 2/3, change it to multiplication, and then multiply by the reciprocal, flip that fraction. Sorry, that's a 7, not a 3. And so we would end up with 16 over 21 if we were to treat that as a fraction, as just numbers. All right, so let's do an example here with a rational expression. So let's take 4x divided by 5x minus 20. And we're going to divide that rational expression by x squared minus 2x over x squared minus 6x plus 8. Okay, so same rules that we had before. We're going to do keep, change, flip first, though. So the first part of this expression stays exactly the same. 4x over 5x minus 20. We're then going to multiply by the reciprocal. So this is going to be x squared minus 6x plus 8 divided by x squared minus 2x. Now we're going to follow the same steps that we did when we were looking at multiplying, which means that we will go ahead and factor both expressions. So we have 4x over 5 times x minus 4. Let's just use the f there. Then factor the trinomial up here on top now. So we have x minus 2 and x minus 4. And that's going to be over x times x minus 2. Here we're going to cancel out whatever we can. X minus 2 will cancel. X minus 4 cancels. And we actually have the x's cancel. X's cancel. And so we are left with just a simplified expression of 4/5. So if you've mastered multiplying rational expressions, dividing rational expressions, you just have to remember to multiply by the reciprocal, and then all the rest of the steps are the same. I think we'll stop our video here.